Well, hello there. Welcome to your everyday math lesson in Ed Puzzle. This is your lesson for 7.6. So 7.6 is a two-part lesson. The part that we did, or the other part that you're going to be working on is about area. You know how to find area. Find a way that works for you. This one is an Ed Puzzle because I want to see what you know about shapes, about geometry, and about what these hierarchy things are. Yes, hierarchy things is a technical term. I'm just kidding. All right, before we begin, I want to see if you remember a few things. If I have a shape, much like my triangle yesterday, I had two triangles that I had. Which kind of triangle had two sides that were equal? What was it called? It was an isosceles triangle. All right, and then we also had a triangle that had three equal sides. A triangle with three equal sides is an equilateral triangle. Equilateral. Now, we also have a just plain old triangle. All the sides are different. This is how this works, okay? If it is a triangle, then it is always a triangle. Sometimes it can be isosceles, and sometimes isosceles can also be equilateral. So it's kind of like a level system. So is it a triangle? Yes, great. Is it isosceles? Yes or no? Great. Is it equilateral? Yes or no? Great. And so this is a way to kind of classify the triangles. You can never go further down if it doesn't match. Does that make sense? So if my triangle looks like this, and this is the sizes of the sides, it cannot go down to this level because not two of them are alike. Which means it also can't go to this level because it doesn't have three alike. Does that make sense? If you start here, it has to be able to go to each level, this one, and then it can go to this one. It can't just jump. That's what I was trying to say. So I know it's kind of tricky. We're going to work with a lot of shapes today. I do want to know if you can tell me a few things, though. So when I'm looking at a shape and I see this symbol, remember that means it is a right angle. It means it is a corner or 90-degree angle. Remember when I see these tick marks, that's what they are called. That means that it shows you which sides are the same length. It shows you this side and this side are the same. And this side and this side are the same. When I say attribute, an attribute is some kind of way to describe the shape. So a way that you could say it is the number of angles, the number of sides, the kind of angles. So you could say 90-degree angles, etc. You could say the lengths. You could talk about the same and different lengths, right? You could talk about if something is parallel. Parallel means it's like the L's, pair of L's. It never touches. You can talk about if it's perpendicular. Perpendicular makes a T or an X. Well, not really an X. It's a T. 90-degree angles. These are main attributes that you're going to be able to see and talk about. So sides of number of angles, sides, kinds of angles. These are things that we're going to look for when we're trying to classify and separate our quadrilaterals. So first of all, a quadrilateral. Well, let's think of the word quad. What do we know about the word quad? When I say quad, that means four. It means four. So a quadrilateral, at the very basic, in order to be a quadrilateral, it has to have four sides and four angles. That's it. It does need to be a closed shape. Absolutely, it does need to be closed shaped. A closed shape, which means that my quadrilateral couldn't be that because it's not closed. Okay, that does not work. All right, so a closed shape with 4 sides and 4 angles. Here we go. Now, we then can separate from quadrilateral, we can then separate it into 2 groups. We can look at trapezoids and we can look at kites. Okay, so I'm going to look at a few different shapes here. So I'm going to start by, and you have these shapes on your page, okay? I'm going to start, or attached to your lesson. I'm going to start by looking at number, let me find it. Hold on. I need number E, and it disappeared on me. Give me just a second. There's number E right there, or letter E. It has 4 sides and 4 angles. Besides that, that's basically it. That technically is my only quadrilateral of the shapes that we have. Okay. Now let's think about a trapezoid. What things does a trapezoid have? Well, 4 sides. That's easy. Ready? 4 angles. Oh, wait, guess what? I don't have to write it again every time because we know it has to have this. Okay? But on top of the 4 sides and 4 angles, because that's what each of these are going to have. 4 sides, 4 angles, 4 sides, 4 angles. They're all going to have that. But this is the test property, which means that if it has at least 1 pair of parallel sides. So this shape right here has 1 pair of parallel sides. I can tell that D, the top right here, and the bottom right here are parallel. They will never touch. There's only 1 set of them, but at least it's 1. That is where you would put your trapezoid. Okay? By the way, this is on page 251 in your Everyday Math Workbook. All right, let's think about a kite. A kite. I know what a kite looks like. I fly one all the time. So a kite has to have this shape right here. 4 sides and 4 angles, just like up here. It also has to have 2 pairs of equal adjacent sides, equal length. That means an adjacent means they touch. That means that this side and this side touch each other and they are the same length. This side and this side touch each other and are the same length. So B is a kite. Okay. All right. Let's look at my next one. So a parallelogram. So if a trapezoid has to have 1 pair of parallel sides, what do you think makes it different in order to be a parallelogram? Here's the picture. So I hope this helps now that you can see it. A parallelogram has, that's 1 set of parallel sides, 2 sets of parallel sides. So 2 pairs of parallel sides. Oops, might help if I spell parallel right. It's not the easiest word to spell. P-A-R-A-L-L-E-L, sides. Absolutely. All right, 2 pairs of parallel sides. All right. This is going to be tricky. I'm going to show you two pieces, and I want you to see if you can figure out the difference between the two. Okay, so I'm going to show you this one right here and this one right here. Technically, they both have two sets of parallel sides. But what's the difference? So I'm going to zoom in a little bit. Let's look at them a little closer. So if I look at this shape right here, I see that they have the four corners, all have the 90-degree angle side. That means that this is a rectangle because all four corners make a 90-degree angle. Do these corners make a 90-degree angle? Nope. That could be one difference that you saw. Also, something that I noticed is on this side, these two are the same and those two are the same. But for A, all of them are the same. So that is our test property. Okay? So a rectangle is this next one. It has to have 4 right angles. I gotta zoom back out, sorry. 4 right angles. A rhombus has to have 4 equal length sides. Done. And finally, we have one more shape. We have shape, and I'm going to get a different one. Hold on. Hold that thought. We're going to use this one right here. Shape N. This one has both 4 right angles and 4 equal length sides. Go ahead and take a minute and write this down. I'm going to zoom out and move so you can make sure that you have it written on your paper. Make sure you have everything on there. Great. Okay. Okay, so what's going to happen is we are going to now look at some more shapes. I'm going to move these kind of out of the way, and we're going to look at this shape. Okay, I'm going to pick a random shape out of here. So let's start at the very top. Does this have 4 sides and four corners? Absolutely. So is it a quadrilateral? Yes. Let's move to the next. Does it have 2 pairs of equal adjacent sides? No, this one and this one are not the same. Nope, that's not the same. Nope, sure doesn't. Okay. Does it have 1 set of parallel sides? Well, that's not parallel, and neither's that. So no. So this shape right here, shape O, is not a trapezoid or a kite. This is just a quadrilateral. If it doesn't meet these criteria and let me do one of those, then it can't be one of those. And it can't be anything lower. Does that make sense? So O is a quadrilateral. Let's try another one. Let's look at this one. Does it have 4 sides and 4 angles? Yep, great. Does it have at least 1 pair of parallel sides? Yeah, sure does. But does it have 2 pairs of equal adjacent length sides? Yep. And 2 pairs of parallel sides? All 3 of those things make this a rhombus right now. Okay. Let's check. It can't be a rectangle because I can't go backwards. Can it be a square? No, it doesn't have the right angles, so it can't be a square. That's how you use this little chart to help you out. Okay, let's do another one. Four sides, four angles. Yep. One pair of parallel sides. All right, I see that this side and this side are parallel. So technically it goes here. Two pairs of equal adjacent. Nope, because that one's the longest. Nope. So far we're a trapezoid. Does it have two pairs of parallel sides? What do you think? Is this going to go down to the parallelogram or will it be a trapezoid? All right, let's try one more. I want to see if we can figure one more out, and this one could be a little bit tricky. Fair warning. All right, here's my shape. Shape K. Option 1, does it have four sides and four angles? Yep. Does it have one set of parallel sides? No, it does not. Does it have two pairs of equal length adjacent sides? So the sides that are touching the same length. Yes. If I look at this side right here and this side right here, they are touching and they are the same. This one and this one are touching, they are the same. So this right now is a kite. So follow that arrow and go down. Does it have four equal side lengths? Nope. So this cannot go any further. That one would be a kite. Does it make sense how this hierarchy works? Now, one thing that you're going to notice and one thing that you're going to be able to do later on, and we're going to talk a little bit about right now, and we're going to do this on the other page, is you're going to learn about the names of all the things. So basically, if I have this shape right here, this is a rectangle, correct? It looks like a rectangle. Basically, everything straight up or everything with an arrow that points to rectangle is also a name for this. This shape right here could be called a rectangle. It also is a parallelogram and a trapezoid and a quadrilateral. This shape right here has four different names because you can classify it four different ways. I can separate it just by four shapes, four sides. I can separate it by parallel sides. Does that make sense? And this little bad boy right here, this shape right here is the magical shape for quadrilaterals. This one has the most names of all. It is a square. It is also a rhombus and a rectangle. It is also a parallelogram and a kite and a trapezoid and a quadrilateral. This shape right here has 7 different names. So if I show you this and you say, oh, that's a quadrilateral. Yup. That's a trapezoid. Sure is. It's a kite. Yes, it is. It is a square. You're absolutely right. But I could put it in any of these other categories. Okay? Now, let's look at page 250, 250. And I know this video is getting a little bit long, but I want to make sure we have a chance to get through this. So, our math message, that is one that we were going to go through a little bit during our Zoom today. So make sure, one of our Zooms here shortly, so make sure you are ready to do this. We're going to see if we can find at least one quadrilateral card that can work with these. We are going to do this together, okay? Number 1, it says, use this journal, page 251, to classify the cards, which we did. From the hierarchy, you can also tell that trapezoids are quadrilaterals, but not all quadrilaterals are trapezoids. That can be seen with those shapes that were kind of like this. That is not a trapezoid. Okay? So now we can do something like this. So I could start here and I could say trapezoid. And you're going to go down, and I'm going to do this a little bit. Let's say trapezoids can be parallelograms. Right? But are they always? No. Are all parallelograms also trapezoids? Yes. So if you go up, that's an always. So all parallelograms are trapezoids. But not all trapezoids are parallelograms. And I wrote that really sloppy, but it's right there next to you. I was trying to write it fast. Pause the video if you need to. All right, and same thing here. I'm going to go with squares. All squares are rectangles, but not all rectangles are squares. That's what I'm going to use for this one. All squares are rectangles. So again, if you go up, it's always. But not all rectangles are squares. The relationship shown in the hierarchy also helps you think about the properties. So for example, parallelograms, two pairs of parallel sides. Rectangles, all rectangles are parallelograms, so all rectangles have to have parallel sides. So all kites have two pairs of equal side lengths that are next to each other. And all rhombuses are kites, which means that all rhombuses have two pairs of equal side lengths that are next to each other. This rule right here, if that's the rule for kites, then it's also the rule for rhombuses. So that's what you're going to write on this line right here. I'm going to write mine, you write yours. Let's go. Don't forget you can pause if you need to. All right, I'm going to use my hierarchy thing, and I'm going to give you the first part, and you have to give me the second part. So just like we did this with this last question, Lord help me today, come on. There we go, ish. Sorry, guys, hang on. My camera is being really wonky. There we go. It's on its own. All right, so I'm going to give you one, and you have to write the next part of it, okay? So all rectangles have 4 right angles. And hold on. Hold that thought. I want to rephrase how I do this. Hang on. Yeah, let's do it this way. All rectangles have 4 right angles, and all squares are rectangles. So all squares, what? What goes in that blank? What must all squares have? All right. I'm going to use this to help me out. It says that all rectangles have 4 right angles. That means all squares must have 4 right angles. All right, I know this is a long lesson. It is a little tricky. I know that we're going to do a little bit more practice with this. This is something that is a harder concept to understand. One of the things that I'm going to suggest to you, and I'm going to make sure it's available for you, is I'm going to give you access to the poster. There is a hierarchy poster that helps you think through this process. And so it is also attached to the lesson. My suggestion, look at that poster, let it help you, okay? I hope that these samples helped. Have a great day, and I will see you later.